Okay, hi everyone. I'll be discussing on the virgin and the emulsified vegetable oil on the turning of a titanium alloy. The presenter is Dr. Ogboo Chikere. And in this particular presentation, the focus will be on the performance using this virgin and the emulsified oil. So what are we going to be looking at? We are going to be looking at a particular alloy of titanium. But before we go into that, we need to look at an overview of titanium. Titanium has been a very important alloy that is used in aerospace, medical industry, and also in specialist areas. Why is it very important? Because titanium has this attractive high strength to weight ratio, which makes it quite acceptable in aerospace and other areas. Then it also have this good corrosive resistance. It is also compact. It has its compatibility with human body, and it can be compatible with composite metal. But before we go into relationship between or how we use the virgin oil for this turning effect, we need to look at what have been we using. Petroleum-based lubricant has been the major oil that have been used for turning of metals in manufacturing. But today we are looking at the application of just the virgin palm oil, virgin coconut oil, emulsified palm oil, and emulsified coconut oil in order to replace the need for this petroleum-based oil. Why do we need to replace it? The petroleum-based oil has its own side effects, which include the health implications, that is when people inhale them during operation, and also the problem of waste management of this oil because they are not biodegradable. But now let's look at what was the first center of our discussion, which will be the research problem. The research problem we are going to be focusing on here will be on the two life. The two life has been affected drastically in most machines, especially for high tough metals like titanium. So the two life will be our focus with regards to this operation. And also, you remember we highlighted that petroleum-based oil has its own negative or side effect with regards to the environment and the health. But also, we also know that the cost of using the petroleum-based oil is high with regards to that of vegetable oil. So the research objective will be mainly to determine the performance of using the vegetable oil, the different types of vegetable oil we are going to be looking into, to cut metals with center on the cutting temperature effect, the tier 2 wears, and the chip reduction coefficient. So focusing on that, how do we, first thing is, what are the methods we are going to apply? The methods we are going to apply is mainly experimental. So the experimental method is we are using the optimum lead machine for our machining, and the tool we are going to use is the uncoated ceramic tool. The uncoated ceramic tool has a radius of 0.8 mm and a thickness of 1.9 mm. This particular tool will be employed to do the machining. But in this study, we are going to use a design of experiment to reduce the number of experiments that will be conducted. So in this design of experiment, we are using Taguchi L16 orthogonal array. Why? Because of it has been proven to give higher performance accuracy. So for us to measure the temperature, thickness, and also the tool where we are going to use the mini infrared thermometers, the vernier calipers, and the microscope, digital microscope, respectively. For this study, we have developed a model for this oil. So we use a normal virgin palm oil and the virgin coconut oil. Then for the virgin coconut oil and the virgin palm oil, we emulsify them. How do we emulsify them? We try to develop an emulsified palm oil by adding the virgin palm oil or virgin coconut oil 32%, the surfactant 32%, and the water 36%, forming the oil, the emulsified oil. Then on the we have used different cutting speed, different feed rate, and also different depth of cut. So the feed rate was between 0.1 mm per revolution to 0.25 mm per revolution for different types of oil. We did the experiment for different types of oil. While the depth of cut was 0.3 to 1.2 mm. On the cutting speed, it was between 90 to 215, where we have 90, 108, 140, and 215. Then after we have started the experiment, we measured the temperature as we showed in the methodology. We are not going to measure the temperature. We are going to measure the chip thickness and also measure the two wear. So the temperature here, you can see the temperature range from 32 up to a maximum of 58.5 for the different types of oil under different speeds, cutting speed, and different feed rates. So, but here we cannot just make a conclusion that the palm oil is better unless we have evaluated other components. So we looked at the signals and we found out that the major signal to noise in the operation during the study was mainly from the cutting speed with regards to the temperature. Then when we looked at the cutting tool wear, we observed that when we use the oil palm, the virgin oil palm, we reduce the rate of wear, where we can see that the wear was only 122.37 micrometer in the operation as compared to other studies. Then you can see from the analysis shown in the previous slide, you will see that the virgin oil palm only gave about 6.44% wear on the tool. Considerably, we looked also at the chip reduction coefficient. The chip reduction coefficient was determined using the fundamental equation where we say is Ks is equal to S1 over Ss, where S1 is the size, the chip size, while the S is the material uncut area, which we can consider as a part of the feed rate. So when we did analysis, we can see that we have different numbers, and based on these numbers, we observed that virgin palm oil was really doing fine. But let's look at other components, which is mainly the noise. So the signal to noise on the chip reduction coefficient showed that the feed rate is a major determinant on this particular area. So in consideration of the operations of this particular study, you see that one important thing is that temperature is reduced with the use of oil palm, while at the same time the tool wear is reduced with the use of oil palm. So in that scenario, we have considered on this type of situation, and after consideration, we can conclude this way that using this experiment, that the use of oil palm gave us a better operational result, and also that the cutting speed is a major determinant in the increment in the cutting temperature, and also the feed rate has a very important contribution in how the chip reduction coefficients are generated. So with this, we say thank you. Thank you very much.